Good morning. My name is Jim Crawford. I'm with the AFCEA Authority chapter here in the Dusty area. We brought together a group of subject matter experts. I'm sure that will be entertaining and help you get another credit for your continuing education environment. This course must run 60 minutes, at which time after the class you'll be able to scan your badges at the back of the class. You cannot scan them any sooner. You will not take it. We've got a new system, so at the end of the class, at the end of 60 minutes, you'll be able to scan your badge, and that information will go, going to be taken down and sent forward to your appropriate agency. This presentation has been approved for one credit for CompTIA and Gaia areas. Also, CertNext is new certification this year. Like I said, we'll be scanning at the end of the class. I won't, but the machine will, so you can get credit. I want to welcome Mr. Stephen Scarborough from Intelligenesis. And he will be our subject matter expert talking on IoT, ICS, and CEMA. Steve, take it away.
Hey, good morning, everybody. Everybody survived the soupy conditions outside, right? I walked out of my hotel and I was like, there's a reason why I moved north. So, like Jim was saying, my name is Steve Scarborough. I will say that if you would like to, all my friends call me Scribs. That's what I'm known professionally and stuff around my office and work and everything else. So Scribs. A little background on myself before I get started. Was in the Navy for 20 years. Retired as CTN chief. I retired here in Augusta, Georgia. I was at NCOIC for SIGINT development. Before then, I was at NSA's Red Team and Blue Team. I was also at the NSA's CSS Threat Operations Center, as well as the NCOIC for their threat branch, their threat intel branch.
I'm sorry, one thing I forgot. Please silence all your phones. Please silence all your phones. Sorry.
No, you're fine. So what we're going to be talking about this morning is going to be kind of an overview of IoT. We're going to throw in a little bit of ICS. I added it over the past few weeks. I figured it was pretty relevant to what we're going to be discussing today. And then note some of those impacts of ICS, IoT environments on the CEMA environment that we're all working within and stuff, right? So I do like participation, so if you have any questions, we do have 60 minutes. I have 3 slides, and I'm going to talk really slow if you can't tell. All right, so we're going to jump in. Seriously, though, if you have any questions, stop me and we can discuss it or anything else, okay? So, like I said, we're going to go over like an IoT primer, what IoT is, and some of the crossovers between what ICS and IoT is, and the tech behind IoT. We're going to talk about some of the protocols that IoT devices are using, such as Zig Beam and ZWave, which are 2 of the most predominant ones right now out on the marketplace. Kind of considered, for those that remember, high-definition discs and DVDs or Blu-rays, right? Same type of competition. They're seeing who can get the market first. And then we're going to talk about the IoT, or Internet of Things, ICS, and how it relates to CEMA, right? From cyber operations, EW operations, and even spectrum management and the IT realm of things, right? And we're also going to touch on some future needs where, in my opinion, right, some of the things we need to focus on as a community within CEMA, within IT, OT types environments, on what those impacts are, on what we need our warfighters and our workforce to be, being upskilled in. Right, so a little history background on ICS. Right, the first industrial control systems came out around. Prior to the 1970s, there were a few around at the time, but not quite at the level that we saw going into the 70s and coming into the 80s. In 1972, one of the first developers built a sensor to monitor, equipment, right? Just to kind of watch and see, so they didn't have to have an employee standing there watching it or walking around watching it or maintaining or controlling or anything else. Early 80s, companies started deploying ICS-like devices and started experimenting and testing with things. Coca-Cola was one of the first companies that did it. And what they did is they filled the Coke machines that reported back temperature and inventory. That way they didn't have to have a Coke guy that was driving around in a truck go and check the temperatures and make sure the Cokes were at the proper level. And also they could know when they needed to go and fill up the Coke machines, right? Didn't work out too well for them, but nowadays if you look at Coke machines, they take credit cards and scan near-field devices and everything else to get it. So, they might have been ahead of something there, right? Come on to the 90s, we had the internet boom, right? We started throwing web pages up and everything else. Companies started getting behind it. We started becoming much more interconnected. If you think about the number of devices we had in the early 90s to the devices we have now, a lot more, and a lot more inexpensive at times, except when Samsung wants to release a new device, right? Or Apple wants to release a new device, right? Early 2000s, we had more devices than humans communicating on the planet, right? So saturating the planet with devices that are actually communicating. That's not just handheld devices or interpersonal devices. If you think about the industrial complexes and the inner workings of all those, SCADA and ICS was all over everything, right? Any place that they could shove a sensor, they were putting a sensor in to help replace having to monitor it in person, right? 2007, the iPhone initiates one of the next biggest technology races on the planet, right? Going to mobile devices that would get them all into our hands. If you think about that to now about how our cars communicate and the information that car companies are pulling off our phone or for our vehicles, whether we know it or not, and using that to affect their environment, I wouldn't say that the telematics coming off of a vehicle would be considered ICS, but if we think about IoT and ICS as an interconnected universe and everything else in the IT, OT realm, it's becoming closer and more converged. Right? 2010, anybody have a Nest? Anybody have any automated housing thermometers or lights in their houses? Quite a few people. It's becoming standard throughout the industry to input those in. Smart homes. Right, 2010 is when the Nest first came on the market. Then started being taken. Honeywell, Nest, a couple other companies behind the big push to automate home temperature controls and stuff. So those things are inside there. And in 2014, Alexis is introduced to the world. Right, Amazon and Microsoft with Cortana and the Google Assistant now are in a huge race to be able to just do whatever you want it to do and control the things in your life with just your voice, and anybody in your environment being able to listen to it, and to control all the ICS and IoT devices and possibly even SCADA devices in the near future. Alexa is really cool. I don't know if anybody's looked at their API for it. You can go in and teach Alexa new skills, and those new skills are pretty easy to go in and set up for specific devices and do other things for you. So you don't just have to control music or buy Tide Pods for future challenges, but you can also go in and start controlling more things to teach it. And then Alexa and Amazon and Google, all of them will then spread that knowledge to the other devices. So creating not an autonomous system, but teaching the system as we go along on how to control these devices. Right. Pretty scary, huh? Right. So what do we have surrounding us today? Not just in this building, but in every place we go, right? So light bulbs. Control light bulbs. I have a home office. I just put LED strips in and control it for my cell phone. It's got a wireless device. I can connect it in through the internet and control it, scare the crap out of my kids, put on disco music and have the lights flash and everything, right? All that kind of stuff. Environmental controls, the Nest, Honeywell systems. In this building, there's industrial control systems. And I have an example of one that I think everybody will find a little humorous and a little scary in a little bit, right? Personal fitness devices. How many of us have personal fitness devices? Like Fitbits and Garmin's, right? Those things are now, right, in that IoT, ICS environment. They're joining networks, they're carrying personal information or PII, they're carrying statistical information about us and feeding that back to locations so we can track our health, but so they can be also flooded into their databases and they can do things that upgrade their devices and their environments and to help other people and everything else. Automobiles, we talked about a few minutes ago. The manufacturers. Anybody have a Mercedes-Benz? Come on, at least somebody's got to have one. Probably not a newer one. I don't have one. I got a little Ford Escape. But even BMWs, Fords, Chryslers with OnStar, those devices now are embedded in the ecosystem within the vehicles that we're using, not just for transportation purposes, but of like over the road trucks, right, through carrying GPS or tracking RFID, but also our own stuff. They take sensor information off the engines, off the vehicle, and report those back. They can predict component failures based off that information, so they can get recalls out and get things positioned ahead of time in the supply chain, right? So they can take all that information and feed it back on and tell you when you need an oil change and when you need a new bolt for your carburetor or fuel injector or whatever it might be, right? Reporting all that back. And you don't have to sign up for that. They built it in. They pay a little fee to feed that information back, right? There's a lot more information that gets fed back than just that at times. Point of sale devices. How many people have bought Starbucks today? How many people have swiped your phone or a card? All right? Those devices are connected in. Square, and any number of other POSs, right? Point of sales, pulling that information back and aggregating it and interconnect it, right? So on a mobile device, they can even have standalone ones that once they get to a Wi-Fi area or another near-field device, NFD, they're able to transfer that information over and execute the bank transfer later on. Refrigerators. Really debating on getting me a refrigerator that's smart enabled so that I don't have to call my wife and ask her if we need milk. I can just look at the camera inside and see what was there. Has anybody seen those on Samsung refrigerators? Pretty nice. Got the TVs on the outside. Don't need to go to my living room anymore. I can just sit and watch TV there. So those devices interconnected, right? Smart TVs. So I think we have to discuss those two in depth. Everybody pretty much has a smart TV now. Some of us have 4, 5, 6 smart TVs in our homes, right? One of the scariest things, well, not really scary, but one of the things that we think about least is the medical environment. Medical devices being interconnected and providing information and accesses. And we'll talk a little bit more about it a little bit later, about the security behind some of these things. But anything and everything that the medical community can do, they're trying to automate. And they're trying to add in interconnectivity so that they can do things remotely, right? Remote surgeries from back in Bethesda to the battlefield. Diagnostic checks on devices and personnel, forward in places. Right? Embedded RFID. And now, why some people say that RFID may not necessarily be considered an industrial control system, the readers and stuff that are in those environments do interconnect with it. We were looking at doing some research and whatnot with a major port in the country, and they are trying to take a grasp on all of the IT, OT things in their environment. And one of the things we look at major shipping ports is the RFID readers, so they can track the containers as they're coming off the ship. There are readers literally every place in that environment, and they're usually connected via Wi-Fi, right, or some other low-level communications device, so they can communicate and track it as it's moving all around. Now, because they're interconnected, and because they're in such close proximity to other devices on the IT field, then they become a susceptible avenue of either attack or exploitation, right, for our adversaries and even for us, right, depending on where we're going at, because they're not just doing it in the United States, they're doing it at other ports and places around the world, right? So those standard practices in those companies putting forward those things and configurations and whatnot, and some of the other places. Right. So the infrastructure we're going to talk about, we'll talk about Zig Beam and ZWave. We'll get a little bit more in depth on those. Wi-Fi, I think everybody in the room understands what Wi-Fi is. So we're not going to go too deep into that. A power line or PLC, power line communications, that is something we don't normally think about from the IT, OT perspective. But transmission and communications across those power lines, either short distance or long distances, the power companies and communications companies using those to their advantages in some underdeveloped worlds and even in some long-haul places to take advantage of those things, agnostic to maybe satellite communications. It might be more beneficial and more cost-effective for those PLCs. Usually done over shorter ranges, right? And then cellular. 4G, 3G, 4G was a big boon for the ICS IoT world, and 5G is going to be even larger, right? We're going to go from billions of devices to trillions of devices, and at some point, it's going to just be even crazier than that. I was watching something the other day on TV, and they were talking about data points on people, right, and things in our environment. And they said that today we have about 5,000 to 10,000 data points for every person on the planet, right? And they say in 10 to 15 years we're going to go up to 75,000 data points. So that's everything and anything that we're doing, and that's going to have to be interconnected in some way and being transferred and be able to haul that volume of data around the planet globally to do the things we need to do on a daily basis in our lives and stuff. And that cellular, that 5G network and beyond is going to be what really interconnects that. And that's going to include the ICS and IoT devices, right, and our other network pieces that we're going to be using or fielding, right, the ITN of the future, right. Think about warriors, every soldier is a sensor, moving into those environments, right, how do they interact with that data? It's going to be coming across cellular, it's going to be coming across satellite communications, intermingled with all these other devices. Right, so a little background on ZWave. Right, Alliance consists of about 450 companies right now, and operates about right in the 908 megahertz range there, especially in just in North America. There's other ranges in other countries, and the way the spectrum management is done globally is a little different. But in North America, that's what it operates at. The transfer rate is around 100 kilobits per second. And you think that that's not a lot when we consider, we're talking about moving at gig speeds nowadays. But for some of these devices, they don't need to move a lot of data. There's just a lot of them moving small amounts of data around the networks in the IoT space, and then out around the WANs and large area networks and stuff, right? So they don't need to move a large data set, just a lot of little packets and little information to interconnect those pieces, right? 230 devices are in a single mesh network, so it does have a little bit of a limitation on what that looks like, but it also allows it to be kind of self-healing. One of the major uses for ZWave is going to be, or for Zigbee and ZWave, is going to be the smart meter environment. Anybody have a smart meter on their home now? Georgia Power or any place you're at, right? So these devices are going to be able to communicate. There's going to be able to, in this example, there'll be 232 smart meters in a neighborhood someplace, right? They're going to be able to communicate. And what they're going to do is move their data, tell your usage back to the power company, and the way they're going to communicate that back is through that mesh network. And that mesh network edge is going to meet up someplace else and then exfil that data someplace, right? Some of these devices, some of these networks will start touching each other, and you'll be able to have more than 232 nodes. And if you think of every house in an environment interconnected, transferring small amounts of data, right, now we can do things from an adversarial perspective, or even we need to be aware of those from a defensive perspective, and not just our personal lives, but in the environments we work in on a daily basis, right? What those things might be, some of those vectors, and how to protect them, and how they're going to impact not just tactical operations, but back home, and we're back in camp, or we're redeployed home, right? And doing those things in those environments, right? The effective range for these is 30 to 40 meters. So again, it's not going to be very far. It's not very susceptible to a wireless capture, if you would say, or interference too far. But I mean, 30 meters with 232 nodes in that mesh environment, then you have a pretty big area covering from what would really seem like a smaller network, but it isn't. Right? I think I skipped a slide. Go back. There we go. So Zig Beam, right? There's over 400 companies in its alliance, and it seems to be the most prominent one right now that everybody is leaning towards. There's about 2,500 plus devices on the market that have incorporated the protocol. Operates in the 2.4 gigahertz band. Anybody know what that band is? Wi-Fi, phone, all those devices and everything else. So it's more common, and it actually makes it a little bit easier to interconnect with our personal devices to the network, so we can control a lot more of those things, right? And it also is where the Amazon Echo works out, Philips Hue, all these things that we were just talking about right around our life and everything else. They're predominantly leading the way to this protocol. Right? Transfer rate is about 250 kilobits per second. Right? Again, it's 150 more K per band. Still not a whole lot, but enough to do what it needs to do, and enough for me or for us. If you think about it, how many devices are in our home that might be communicating on this? We aggregate that bandwidth. How are we going to get things out? How are we going to do things? How susceptible does it become? Right, to do those pieces. 65,000 devices on a single network. Think about that for a second. 65,000 devices on a single mesh network working at the 2.4 gigahertz band. That's an entire neighborhood. That's even some small cities here in Georgia, right? Interconnected devices that corporations and local governments might have on the network and stuff. So, and all those things, right, we have to be aware of. We talk a little bit later about the environments, like from a defensive purposes, right? What are those things? What are these devices doing? Who's brought a Amazon Echo to work? I know somebody has. How many people have brought a smart TV to work? Or had a smart TV roll into their office, right? How many people think about that before we buy stuff for our offices? Right? A couple people, right? You wouldn't. I was at an agency up in the D.C. area, and they rolled in brand new, 60-inch TVs on rollers, so we can move them around the awesome open office space. And we turned it on, and I was sitting there looking at it. And when I looked at one of the guys that was looking at it, and I'm like, Is that light blinking? And he's like, yeah. So we grabbed the remote real quick. We opened up the settings and everything else. And the company who purchased it for the entire agency, right, had bought about 400 or 500 of these and rolled them throughout the entire complex, and had forgot to disable the wireless on them. So wireless TVs, smart TVs, sitting in these offices, highly sensitive areas, right? Just don't think about it. That's where these devices and stuff are going to be at. Bringing these pieces in and out of buildings and intercommunicating, right?
One more introduction to your network.
Yep, it's another vector for either exploitation and defensive needs, and we also have to think about it from the other aspect of CEMA, right, or CNA, or offensive operations. How do we leverage these types of things in the future as well for our advantage, right? We already talked about ZWave, right? So industrial control systems, right? I'll talk about those really quickly because I think it's very important that we start having that conversation as the network grows, right? As we move to 5G and higher network speeds of the future, right? Companies are going to look to consolidate management of these things, and the IT or the IoT and the ICS realms are already converging, right? And they're going to continue to converge as more connectivity and higher bandwidths are capable to handle all the devices, right? And 5G is going to be the big jump, right? So what is ICS, right? It's usually what we think of when we talk about controlling heating or cooling in our offices, controlling the lights, or any other things that we might want to manage remotely, right? And to try and automate within our lives. Not so much communicate with things like the IoT devices and stuff, but how do we drive and do things in these environments? It used to be you had to go to every light switch in a building and turn off all the light switches, and you had to go and manually set the thermostats for the each partition space and all these other things. Now it's all automated. You can sit in one control space and say, I want a much cooler temperature in room A, and I need the lights dimmed to this specific level, or I need to turn off all the lights and do all those other pieces, right? We don't think about those when we come into buildings or even when we start working in a new building. or when we see facilities personnel bringing new equipment in, right? That's probably one of the biggest things we've seen. I work with a partner who trains ICS, and he has many, many years of doing assessments for ICS stuff, and you would not be, you would probably be amazed at the number of things that he's found that are just ridiculous, especially if you ever worked on like defensive cyber operations. To go in and see some of these things that vendors are doing, and I'm going to have a really good example again in here in a few minutes of vendors not understanding what they're putting into our environments, right? Not because of any maliciousness, but just because of the way they do business and the way they've been trained to do things, right? So again, power plant turbines is another place, right? Windmills, solar cells, anything else to do with power generation. There's probably some industrial control system inside of there. On the infrastructure for those pieces, moving between substations and whatnot, there are intercommunication devices or industrial control systems to manage and regulate the power flow through those pieces and report that information back to the power plants and the control stations, right? And automated workforces. And people are like, well, what is an automated workforce? Anybody ideas? Automated workforce? Robot. Kind way of saying robot, right? So anything that we can do, not to replace humans, but to do kind of a repetitive task over and over again, those all have to have some sort of control system embedded into them so that we can maintain and monitor those and get information back of if they're operating properly or not. So each one of those devices inside of a major network or inside of major corporations or factories or any other place will have some sort of industrial control system implanted on it or functioning, right? And you can kind of see just a little graphic of those pieces. The distance between ICS devices is only limited by what the communication device is supporting it. So we've seen some places, some power stations, even Camp Pendleton in California, they have remote power stations or substations within Camp Pendleton that are hooked up to a GPRS network and feed back information over the cellular data, right? And not just via landline. So some of those pieces could be out there, right? Some quick terminology, just so everybody's on the same sheet of music. We routinely talk about, again, we're talking about IoT and ICS, but ICS encompasses a lot of different things. One of those things is SCADA, so supervisory control and data acquisition systems. Those have traditionally been associated with mainly building facilities and power plants, and there's a lot of them in like nuclear power plants. Right, to bring back information, temperatures, and to gather all this data back about how the power plant or how the facility is operating and be able to monitor all these different points. When you talk about power generation, right, there's a lot of different variables that you have to maintain and monitor. Same way with cooling and everything else, but power generation has always been probably the biggest place where SCADA has been put into place. PLCs, right? PLCs are programmable logic controller, and they're just small boards. You probably have seen them, but not really recognize what a PLC is. It's a solid-state computer, right? It's customized with a very explicit set of instructions on how a device is supposed to operate, right, and do these different types of things. A lot of times it'll be I don't know why it keeps doing that. Stay. Now I lost the train of thought. A lot of times there'll be a ladder logic embedded into those. And anybody familiar with ladder logic, right? It's an on-off switch within the logic. Simple things like traffic control lights, right? All of our traffic control lights, most of them work off a PLC that have programmable logic within them, right? And it just says, turn the light red, turn the light off, turn the light red, turn the light off, right? HMIs, or human-machine interfaces. These are how we... It's going to test me. These are how we interact with these devices in the field. So if you've ever seen just a pop-up, like an app, to control your Wi-Fi lights, the hues, right? You pull it up. it makes it easy for us to operate and stuff. Modbus, BACnet, and there's probably another 15 to 20 protocols that the ICS devices are working on. Modbus and BACnet are probably the biggest ones out there. Modbus has been around, since 1979. As most ICS devices communicate across that, but there's some other ones, right? Industrial Ethernet. Again, I'll just leave it. We'll go back to it. So industrial Ethernet. I think again of power line communications, right, or internet over or power over Ethernet, or any of those types of things, right, where we can transfer communications over non-traditional medium, right. We think about twisted pair or something else. That's something we would consider being a network medium, not necessarily plugging into the outlet and transferring communications across it, right, on a daily basis. It is in the home marketplace. But most people don't use it, right? It lost out to Wi-Fi pretty quickly. Right. Here are some just some images of what a typical ICS device would look like. Somehow I turned timing on my thing, right? Maybe the computer's trying to tell me to hurry up a little bit for you guys. Right, so water control systems, we have an HVAC controller up here and a GSM GPRS module that can be attached to a device someplace or to a substation, right, and transfer information out to a different location and everything else. We traditionally don't see these in a room here, but I can guarantee you that there's probably one in the overhead. There's something probably attached to the vent up top there. And any place else, if you look behind the curtain, right, you pull back the curtain to Oz, you're going to see all these things. When I was mentioning a little bit earlier, some of the things that installers do, right, is they'll come in and they'll just pull whatever off the shelf or anything else, go up, drill a hole in a vent and pop it in and run some wires off of it and stick it into your Ethernet, right, RJ45 connector or whatever it might be. And never talk to the IT guys in the building and just shove it in there and just go, right, without any concept of ramifications of adding something like that to it, right? Or adding something like a GPRS module to your environment that you don't control, right? Feeding information about your facilities and communication in your environment out to somebody else that really probably doesn't need it, right? They might have contracted it through facilities, but facilities is just thinking about operating the building and not defending the building, right? And not defending its occupants. So those are some of those things. We try really hard, and I'm not going to pick on the Marines. Any Marines in the room? I thought I was going to be able to use a whole bunch of jokes, but now I got to be PC, right? Try not to pick. Yeah, just drawing crayons, right? Not going to pick on them too much, but we were doing some research not too long ago on ICS, and we're trying to come up with a brief, and I think these couple examples are really cool. A brochure, the Marine Corps is trying to introduce smart energy and smart control, and there'd be a kinder, gentler Marine Corps on the environment, right? These different types of things. They have a pamphlet that they've done. They had contracted out and said, hey, go and make this so we can give it out to all the Marines and make them all aware of all these things. This actual image from it, it's a power meter that's on Camp Pendleton. You can see it looks to the uninitiated, right, it might seem kind of just normal, but if you look a little closer at it, the highlighted areas, there's some things missing off of it that look kind of out of place, like there's some blanks. Well, they tried to obfuscate some of the information on it, right, and they did a pretty good job, except they left the original out on the internet, right? So we started looking at this, and now we can see it was actually at Camp Pendleton. We actually have a MAC address. We have a device type, so we can go and pull this device up. We can see anything and everything about it just from a quick look, right? You probably walked by 100 or 1,000 of the things in your life, and these are going in more and more across the country and more in our environments, right? On base, off base, and the environments we're deploying to, right? They're moving it in. And some of the places where we deploy to or do detachments to, you can bet they're trying to put these things in so they can manage them over long distances and don't have to send somebody out to the middle of the sub-Sahara to check a power meter or power consumption, right? They can just see it wherever it's at. And we have to be aware of these things, too, from our perspective when we start going in and we start looking at things like, are we compliant in our building or are we compliant in our IT infrastructure? Are these things out here? What exposures or what vectors are we exposing out to the environment? Right? Who has not ever seen Showdown before? Everybody's seen Showdown. Showdown is a nice little tool. Some folks like to call it, Google for hackers, right? It's open source. All these devices we have in the world that people go to Costco and pop, $400 or $500 down for cameras to go and monitor their homes or anything else. They put that on the network and they never secure it. They never do anything else. We're just as bad about it. And this is one of the things to kind of highlight about what we need to do with vendors and things. Not going to pick specifically on the one. But go to Showdown. We've been doing some research and stuff on ICS and other things. And I was actually showing a group from San Antonio how to find gas stations in a local area and see how much gas they have in their tanks. And you can just go to Showdown and type in Unlit, right, and start doing some other things. And started poking around and looking for some stuff, right. I found the water controller for the main valve coming out of a water reservoir for Wichita Falls, Kansas. Is publicly available, right, and not secure. So we called them up and be like, hey, you might want to do something about this. But this one, I think, will drive it home a little bit more for us here, right. Did a search, doing search for ICS stuff. I can see I got some results down here for Columbia and Charleston and Rock Hill and Mount Pleasant and Simpsonville and some other places, right? The Columbia one interested me, and what we're looking for is port 4780, and I've refined the search to include South Carolina just so we can get it down there. 4780 is for a specific device, and it's BACnet. I don't know why it's moving on me here. So we did the search for it, and we start looking through, and we found this device here, and it has 80, I think 443 and one other port open. The city that it resolves to is Dalzell, South Carolina. Does anybody know where Dalzell, South Carolina is? It's just outside of Columbia, South Carolina, right? It kind of throws a researcher off because they're like, well, what could possibly be in Dalzell that's of interest to me? And if you look a little closer at the UDP port for BACnet, sorry about the thing here. When the installer put this device in, right, it's I'll show you the device here in a second. He named it appropriately for the location he was putting it in. And you can see up here where it says object name, it says Adj General. And if you look down at the description, it says Adjutant General. Huh? For the state of South Carolina. So we go and we look at the device, we look it up, and we see that it's a network automation. It's basically a supervisory device for all the other devices within the building. And because now I know it's in Dalzell, I know it's close by Columbia, South Carolina, I know that it's Adjutant General. Just go on Google. You can see Dalzell's highlighted here, and Columbia's over on the right-hand side. We zoom in a little bit, and then there's Fort Jackson, right? On Fort Jackson, in the southeast corner is an old building that was labeled Adjutant General. At some point, they've moved downtown. We're off the campuses of USC there. Right. Nice little vector into it. You can go to it. Luckily, they have it password protected, so it's a little bit more difficult to the casual user to get onto it. And I say casual because there's no really other protections in place for it. It's just out there. The thing that concerned me most, aside from it being out there when I first saw it, is if we go back and we do a little bit more digging, the installer also installed the same devices on 3 other locations in Columbia and used the exact same architecture for it. So all I did was just basically image each one of the devices and install it with the default settings, right? And those other two devices are at museums. There's a museum right here off the compound here next to the Adjutant General. It's a museum for the Guard in South Carolina. And there's another one downtown. I haven't been able to pinpoint it quite well, but I think it's probably the Children's Museum or something else that's in Columbia. So what that affords me, right, when we don't think about it, is the opportunity to go and test things, right, to test exploits and stuff on a network where the museum IT staff is probably not going to be, up to the same speed as some of the personnel in this room, right? They're going to have baseline network defensive skills, be looking at a log, all those pieces. So what I can do is I can prepare at one location and then go and really shut down and mess with and do things with the Adjutant General's building. Anybody know what's at the Adjutant General's building? South Carolina, what they're really not really known for, but one of the biggest things, have some CPTs out of there, don't they? Like Army Guard, cyber protection teams, hosed out of there. So I shared this with somebody a couple weeks ago, and they were immediately on the phone to the Adjutant General's building. We're like, hey, you should really look at this. These things are out there. We just have to be mindful of it. And this isn't a ding on the facilities or anything else. It's just something that they contracted out. It came in and popped into the building and didn't think about it, and now it's out there on the network. And I can tell you that the Adjutant General's building is not the only one in the government that is exposed that way. There's a major information systems agency that their building does the exact same thing. Right? So how do all these things tie into CEMA? Right? And why we really focus on some of these pieces, what I've been talking about, right? So the core tenets of the CEMA environment are attack and exploit the enemy and our adversary systems. They use the exact same technology, and they do the exact same things as us. One of the things I've taught over the past 9 years as a mentoring network analyst and defenders and attackers and everything else is you have to just think of the other person on the other side as somebody who's just like Joe Schmo at the gas station down the road, right? They come in, they do something, they set it all up, and they may not have any idea of the ramifications of putting that device in their building, right? So how can we exploit that? How can we use that for several different pieces, right? We have to think about when we're talking about building and operating and defending our networks, right? How do these things impact us as we move our mobile data centers into a combat zone, right? Into an area. How do we set up forward deployed pieces to support the ITN and the soldiers in the field, right? All these other things. We take personal laptops into that environment. We take personal communication devices. We did a survey for a tool off of a ship in Charleston, and they provided me the PCAP back, and the system had recorded every person's Wi-Fi WAPs that they were been bleeding back off of, right? So we got this PCAP, and it was like Long Star Steakhouse and Joey's and Hooters and all these other places. And I'm like, what the heck is this, right? And realize, hey, the crew's personal information is being sucked up on this piece and this network monitoring device, so we need to go and set up some filters for it and everything else. So as all those pieces that revolve in there, as we deploy, as we go out to the field, right? We do a weekend trip to the range or something. We're taking mobile devices, taking laptops, we're taking our Alexa devices and whatever it might be to entertain ourselves, and Xboxes, PlayStations, right? Gaining situational awareness. So this is probably one of the coolest things, and I think that most people kind of overlook is the amount of data. Is anybody going to my data science session later on today? We kind of talk about it a little bit there. But being able to look at their environment from all the open data that's available, to be able to go to some place like Showdown, pull up information, and just do some simple discovery. The queries I did to find the Adjutant Generals, it probably took me about 15 to 20 minutes of just poking around and actually stumbling across it because it said Adjutant General. And me being a military guy, I go, oh, that's my turkey right there. Right? That's the one I'm going to go after. Right, but there's a lot of different things we can use as we go into to move into environments, right, and protect the individuals and platforms. We're going to interconnect all the soldiers, all the sailors, all the airmen in some way, form, or fashion. We have to understand the impact of all these other devices that we're intermixing in these environments that we're putting together, right? What does that smart device on their wrist do, right? They have an Apple watch, or they have a Samsung Galaxy watch or something. What does that device do to the capabilities that they're deploying to the field, right? Whether it might be equipment or their own personal stuff, right? So understanding those pieces. And what vulnerabilities are they exposing back at headquarters areas or back in the rear, right? What are they exposing at the hospitals, right? If I really wanted to cause some damage to a location, thinking about like attacking something, attack the supply chain, right? Or attack the supply chain of the hospital that didn't think about their interconnected devices and have something sitting next to a refrigerator that contains all the insulin for a community, right? Expire the insulin for a city and see what happens, right? So all these little devices and everything else provide vectors and jump points to get to those things that we traditionally just don't think about, right? Right? The saturation of devices and that are communicating, right? 5G is going to be really awesome. It's going to allow all these devices to communicate. But we really get into this environment. We're moving into places on how do we leverage analytics and make our defenders and our attackers and aware of what's going on, and how do we protect our data and our communications, our devices in that saturated network, right? Because we're going to be using things that are working on, 2.4 gigahertz, and we're moving into environments that use 2.4 gigahertz. How do we protect those things and allow us to also simultaneously use that environment? The wealth of information out there, right, for our strategic and tactical information. Again, because of all these devices, because they're all talking, they give us each a new vector to be able to identify and maintain informational awareness of say, a city or location we're moving into. In my data science class, we'll look at, I was recently at DHS's ICS joint working group meeting that was held in Kansas City. And we're sitting with my partner, and he's been training and doing ICS work for 10 to 12 years. Probably one of the smartest people I know in the environment. Is a tinkerer. He invents things, and he can capture stuff. I mean, just this amazing person to sit and walk with. And I kept telling him, I'm like, you have to listen to what the conversation is. And by lunch the second day, right, because I'm a data guy, data science, network intelligence, threat intelligence, everything else, I kept telling him, I'm like, data. And by lunchtime the next day, he's like, I totally get what you're saying now. He's like, because everybody in the room, whether it was a vendor here or a vendor there, or a commercial entity or a network security guy for a shipping company, are all coming in and talking about the same thing. Like, what can we do about the data? Because there's so much of it, right? And there's standard communications paths, but there's no real hard and fast standardization for communication interchange or data formats for the interchange. We can have in JSON or XML or CSV or any of those other pieces, but how do we take all the information from all these thousands and millions and billions of devices and make an environment in which we can understand, right, to help us, and with our situational awareness, right? Situation is for close-in operations. So being able to give that ability to warfighters that are be going into close proximity operations that understand what's in their environment, right? Feeding information out, being able to look at it. We mentioned Nest earlier. One of the things that I think most of us don't think about is like we know about counter IED operations, right? We know how that they were building those pieces out. We know that it could be remotely detonated and everything else via mobile phones and all these other pieces, right? Have we really thought about what a Nest can do? Right? Anybody know what a Nest, one of the basic things, operations a Nest can do? Or what it collects? Based off of what? User input or time and motion? Right? All of those. The biggest thing would be motion, though. I could put a Nest in my in my layer, my secret layer, right? I put it into the front door, and it would be innocuous to anybody walking into it. It'd be like, oh, there's a Nest controller. But if I rigged it up to explosives or rigged it up to something else, somebody comes in the door, it trips it, blows everything else up, right? So all these other little things. I could train Alexa a new skill to listen for U.S. soldier, get down, and do something else, notify me. And I don't even have to be in the area, right? We can do those different types of things. So all these pieces, right, need to be now become part of our mindset and our ethos on what we're going to do in the network and in cyber environment and stuff, and how it influences all those pieces moving forward, right? Complex electromagnetic environment. With all these devices, right, it may be interconnected via Zigbee or ZWave or 5G or GPRS or anything else, right? We now become a little bit, the electronic warfare environment becomes a little bit more difficult, because what environments or what protocols are we going to be operating on? The same ones we're going to be attacking, right? And we're going to be putting those pieces in, those sensors into those locations, and putting it on transportation devices and everything else, and having our people close into it. So how do those environments and understanding where we're going and having the capability to adjust our capabilities to offset the environments we're moving into as we employ and deploy those pieces into it. And spectrum management effects, right? I know that spectrum management is probably the least sexiest thing in CEMA, right? Any spectrum managers? One in the room, right? So how do we, when we're looking at being able to set up backhaul communications, what volumes of information are we going to be needing, right? How are those things going to affect those pieces? And if I say volumes, I'm not talking about just our data, but data that defenders, right, and network operations people and everything else are going to need to be going out and getting. Has anybody ever looked into opendata.gov? I would say today or sometime in the near future, go and look at opendata.gov and just go look at open data in general and see the vast amounts of data publicly available to us and publicly available to the world, right? And we start thinking about having to try and pull down some of those data sets and use those to our advantage, right? And building out some of these situational awareness pieces and stuff. But we're going to need the bandwidth to pull that information in rapidly, do the things we need to do. When we talk about mobile data centers or mobile clouds, right, moving those forward in support of operations, those things are going to need huge pieces of bandwidth to move it back. I'm sure we have that in place, but spectrum manager, we have to be cognizant of those pieces, right? And our defensive side will need that as well. I actually have it here. So I forgot I put it in last night and didn't move it up. So this is one of the things I showed him. We were talking about data there at the ICS Joint Working Group. And he finally said, I get it. And I started talking about, the need for our network defenders and our ICS people and everything else to really start uptaking data science skills and learning some of these pieces. And while it's not super complicated or anything else, this piece, I sat with him for about 10 minutes. I went to Open Data Kansas City, right? They have a ton of information available out there to him. And he's like, yeah, but what does that have to do with the ICS world? Well, the data points we're seeing on here are actually from their dangerous buildings data set, right? So condemned homes, condemned offices, things that aren't within standards. They issue these things that have a geo location for them. So with about 7 lines of code, I went to their data set, pulled the data set in. I've got it mapped on the map and everything else. And he's like, I still don't see where the ICS is. I'm like, well, if we go and we look at those buildings, I'm pretty sure they're going to have a smart meter on it, or they're going to have some industrial control system on it. And they're probably going to be empty or something else there. So as unattended, right? So if I was going to take over and do something in Kansas City, I needed to have an available infrastructure. I could just go and start looking at these and say, okay, who are these registered to? Is this a corporation? Is that a building? If I want to do a little war driving, I can go out there and visit the building and not to be worried about some homeowner or a facilities manager running me off. I can just go out there and hang out and play with the device, all these other pieces. Same thing works in other countries, right? They put their data out there. I was looking last night. There's data for opendata.iraq. There's opendata.china. I don't trust the open data to China data. But they're out there. These places have this data available to us. And it's not just network information. It's also statistical information for, populations, all kinds of other things, right? We can aggregate. But within just a few minutes, I'm able to go in and provide situational awareness on condemned buildings and dangerous buildings in the area. Same way in Showdown, looking for gas tanks. Right, looking for those gas tanks, able to pull those pieces up and see where gas is at. They install these devices. I don't think I might have it in here. Yeah, I have it in here. So this is the one search I did for Unlit. That's all you got to search for in Showdown, and you can see a gas tank. And you'll notice it's a little bit difficult to see. I apologize, but there's two things here. One is this. Lantronic device, and I'll show it to you here in a second. And down below here, it actually shows it on there. It's like 5 minutes. Oh, cool. It actually shows the volumes and temperatures for the separate gas tanks. So unleaded and diesel and premium and all those pieces down here on the bottom. But the first piece up there is a telnet that's open, this Lantronic device. And Lantronic device is pretty sweet. The other nice thing is you can't, a little hard to see here, but they actually give me the address of the gas station. So just go and Google search it and see that it's on in New York. And there's literally thousands of things all over the place. But I could pull it up and see because I know that it's a Lantronic. It says so right inside the session there. So I just go out and I do a quick look for the Lantronics XP. And this is just a little serial to Ethernet device. It has a web server. It has a mail server. It has all kinds of other stuff on this little device right here. And it just takes the information right off the reader for the tank and plugs it in the RJ45 and gets on the network so you can see that stuff. You can't see from this picture, but it says you can go out to it. I wouldn't suggest doing this. I'm not condoning it anyways, but the person who installed this didn't set up the password for it. It's the default setup. So I can just telnet into it and turn on the web server and the mail server and everything else. Literally, again, thousands of these things. Scary from a defensive purpose, but super awesome if you're an offensive cyber guy. Or if you're going into the area and you need to move cars someplace and you need to know where gas is at, what gas stations have gas. These devices are out there, so we can do all kinds of different things with it. Again, just search for Unlit, found some ICS device that you normally wouldn't think about when you go to the gas station. And I've seen other gas stations all over the U.S. and all over the world. Germany, England, France, Italy, right? And they're kind enough to, again, put me the address in there, right? So really quick, I'm going to run through these last ones, right? So cyberspace operations, ICS, IoT, right? We need to be thinking about from offensive, just like we were talking about, right? Preparation of the environment. Before we go in someplace, what open data is available to us and what ICS or IoT devices are in those areas, right? That we can leverage to our benefit to, again, gain that situational awareness, to map it out and see what all is there. Right, and then also for the close-in support, what are those things that we need to provide to the soldiers and the Marines that are out there as they are dismounting and going on foot? What do they need to be aware of, and what devices and information we can provide to them? Hey, you're going to this neighborhood. This has this device in this area, right? Defensive considerations, right? Unintentional insiders. These are the guys and gals who are bringing Xboxes and PS4s and wearable devices and anything else, right? Google Glasses, whatever it might be, or anything else that might need to automate their lives. It's becoming more and more prevalent, so we need to be paying attention to those things. It has unintentional impacts on our infrastructure, right? Our spectrum management and our backhaul communications, right? And again, an increased threat from just the sheer number of those potential vectors, right? Of those threats that are coming in, whether intended or not. right? We just have to be a little bit more cognizant of that, right? Electronic warfare side, right? The market is still establishing the standards, right? We can kind of see where they're going with it, but that will change too as 5G and LTE beyond becomes more and more prevalent, right? Filling those capabilities, right? You mentioned, less appealing aspect of CEMA, the spectrum management and the IT piece. The IT folks, IT practitioners, defenders and stuff, the service providers need to be made aware of those things, right? The volumes of data we need for data science. And for the IoT and ICS capabilities, how do we allow our soldiers and sailors and airmen and Marines to do the things they need to do and for morale and everything else with some of these devices and how they're going to use them for their future and how we're going to protect them and everything else. Operators, right, what we need, right, is multidiscipline operators that understand these types of things. We can't just say a soldier who's dismounting on foot doesn't need to know about cyber operations, but they also need to know about how it can help them do the things they need to do locally, not just from traditional OCO type things, but hey, can you, my back-end support, can my J2 provide me some situational awareness of interconnected devices in my environment, right? Some of those different pieces, right? Data analytics, volume, right? And I like to think it's the insurance commercial like free. I'll say data, right? Data is your friend. It's your enemy. It's out there. There's lots of it. We need to be more cognizant of it, and we need to learn, pick up some skills on how to manage some of that data and work through some of those pieces. Data science, scientists and analysts, right? Converging those roles a little bit more and getting them a little bit closer, and picking up some of those skills. Where we might not be a full-blown data scientist, need to have some data science tendencies, right? There's tons more to talk about ICS, IoT, CEMA, right? We only have an hour. But I would challenge you, go out, look at some of these things, look at some of the open data, look at Showdown, go out there and look at those pieces. When you get back to your offices and you get back to your facilities, walk around and just look at things and touch and ask questions. Be like, what's those two wires sticking out of that vent, right? You'll be surprised, right? And the ever-changing in technology, right? Because of the rapid development of technology, because of the internet, because of communications advances, we could quickly and rapidly do new and cool things. That puts a challenge on us to need to quickly and more adeptly pick up those same skills and work with, right?